Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about double angle and half angle identities. So the double angle identities are right here. So for sine, we have sine 2a equals 2 sine a cosine a. For cosine 2a, we have three different forms. So the first one involves both sine and cosine. So we have cosine squared a minus sine squared a. The second one is just in terms of sine, so we have 1 minus 2 sine squared a. And the third one is in terms of only cosine, which is 2 cosine squared a minus 1. And we can use any of them depending on, for example, if we are just given sine and we want to find cosine 2a, then we can use the middle one. So we can choose which one we want to use. And then for tangent, we have tangent 2a equals 2 tangent a over 1 minus tangent squared a. So we are not going to prove this, but these can be proved using the sum formula that we discussed in the previous video. So the first one, we can prove this one by using the sum formula for sine a plus b, but here we have 2a, so we can write a plus a, and then if we use that formula, we'll be able to prove this one. Again, we are not going to prove this, so we are just going to use them here, okay? So now if we take this one, last two double angle identity for cosine. So for example, if we take this one, so cosine 2a equals 1 minus 2 sine squared a. So if we take that one and solve for sine squared a, we will get this one. Similarly, if we take the last one, so cosine 2a equals 2 cosine squared a minus 1, and if we solve for cosine squared a, we will get this one. And then for tangent squared a, we can do sine squared a over cosine squared a, and we'll obtain this one. So these three identities that we have here are very important, especially when we go to calculus courses. We need this one, so these are very important. Okay. So let's look at the first example. So here we are given tangent theta equals negative 3 over 4, and theta is in quadrant 2, and then we are asked to find sine 2 theta, cosine 2 theta, and tangent 2 theta. So just be careful here. We are given theta, so tangent of theta, but we are asked to find sine of 2 theta. That means we are asked to find the double angle here. Okay, so basically, basically we are going to use the double angle identity. So, but before that, let's go ahead and draw that reference triangle here. Okay, so the angle is in the second quadrant. So let's go ahead and draw it here. So it's in the second quadrant. So let's draw that reference triangle. So this is the angle theta, and then this is the reference angle. Let's say theta r. So we're given tangent theta equals negative 3/4. So we know that tangent equals y over x. So it is 3/4, and we know that x is negative in the second quadrant, so it's negative 4. And then we can find r equals, so 3 squared, square root of 3 squared plus 4 squared is square root of 25, which is 5. So from here, we are already given tangent theta equals negative 3/4. That's the tangent. Now we can find sine theta equals y over r, which means 3/5. And then cosine theta equals x over r, which means negative 4 over 5. So using this one and using the identities, now we can find the values for this given functions. Okay, so let's go ahead and find the first one. So we have sine, so A is sine 2 theta. So the identity for sine 2 theta is 2 sine theta cosine theta, which equals 2 times, so sine theta is 3/5 times cosine theta is negative 4/5, and then if we multiply this, we get negative 24 over 25. Now let's go ahead and find the next one, which is cosine 2 theta equals, so we can use any of these identities, so we have three of them. Let's just use the first one, okay, which is cosine square theta minus sine square theta. We know that cosine theta is negative 4/5. So when we do negative 4/5 square, that is 16 over 25. Minus sine theta is 3/4. So when we square, we get 9 over 25. And then 16 minus 9 is 7. So 7 over 25. And then C, we have tangent 2 theta. We can find this in two ways. We know that tangent 2 theta is sine 2 theta over cosine 2 theta. So if we do sine 2 theta over cosine 2 theta, cosine 2 theta, which is sine 2 theta is negative 24 over 25, and then cosine 2 theta is 7 over 25, and that gives us negative 24 over 7. So that's how we can find it, or we can also use the double angle formula for tangent. So you can try that. We can use this one and we can get the same answer. Okay. So now let's go ahead and look at another example here. So we're going to prove the identities here. Okay. So the first one, I think we are just going to do one example here. So um, in order to prove this identity, we are going to take the left hand side, which is 1 minus cosine 2 theta over sine 2 theta. Let's go ahead and use the double angle identity for cosine 2 theta and sine 2 theta. So 1 minus, so for cosine 2 theta, we can use any of them. I'm just going to use this one, 1 minus 2 sine square theta. Okay, so 1 minus 2 sine square theta over sine 2 theta means 2 sine theta cosine theta. So this gives us 1 minus 1 plus 2 sine square theta in the numerator divided by 2 sine theta times cosine theta in the denominator. So 1 minus 1 is 0, so we have 2 sine squared theta divided by 2 sine theta cosine theta. So here we can cancel out 2 and 2, and then we can cancel one of the sine from the numerator. So this gives us sine theta over cosine theta, which is tangent theta, and that is what we have on the right hand side. So we just proved this identity. Now let's look at half angle formula. Okay, so half angle formulas are obtained from, so we can use just the double angle formula to obtain this half angle formula. So if we go back here, using this, we can get the half angle formula. So from here we have sine A equals 1 minus cosine 2A over 2, and this is under the square root, and then we get positive or negative. So now if we replace if we replace A with A over 2, okay, so sine A over 2 equals positive negative square root of 1 minus, so cosine 2A, if we replace A with A over 2, we get cosine A over 2. So this is exactly what we have here as half angle identity right here. Similarly, we can obtain for cosine, and then for tangent, we have three different forms. So we can use any of them based on what we are given, okay? So let's look at some examples using these half angle identities. So first one is asking us to find the exact value. So we know that 22.5 degrees means half of 45 degrees. So we can rewrite this as cosine, this equals cosine, so we can write 45 degrees over 2. Now we have a half angle, so 45 over 2, so this is same as cosine A over 2, which has this formula here. And we know that this angle is in the first quadrant, so it is positive. So cosine of any angle in the first quadrant is positive. So we'll just take the positive value of that as square root, okay? So it is 1 plus cosine A, so A is here 45, so this is A over 2 means A is 45 degrees over then this 2 here in the formula. So this equals So 1 plus cosine 45 is square root of 2 over 2 divided by 2. If we combine the fraction in the numerator, we get 2 plus square root of 2 over 2, then divided by 2. So if we combine that fraction, we get a square root of 2 plus the square root of 2 over 4, which is square root of 2 plus the square root of 2 divided by square root of 4 is 2. So this is the exact value. We are not going to put it into the calculator. Now the next one, sine 15 degree. We know that 15 degrees is half of 30 degrees. So this can be written as sine 30 degrees over 2. And then we'll use the half angle formula for sine. And again, this angle is in the first quadrant, so we'll just take the positive value. So we have 1 minus cosine A, so A is 30 degrees, over 2. And then we know that cosine 30 degrees is 1 minus cosine 30 degrees is square root of 3 over 2 divided by 2. Now if we combine this, simplify this fraction, we're going to get 2 minus the square root of 3 over 4, and then that can be written as square root of 2 minus the square root of 3 over 2. And that's the exact value for sine 15 degrees. So now let's look at this example. Here we are given the angle in the second quadrant, which is negative 3/4, and then we are asked to find the angle in the first quadrant. So now what we know here is the angle is in the second quadrant, so the tangent is negative here. But so second quadrant means, so theta is in between, so sorry, theta is in between 90 degrees and 180 degrees. So when we take the half, so we are finding sine theta over 2, cosine theta over 2, and tangent theta over 2. So we are taking the half of this one, which gives us 45 degrees. So theta over 2 is in between 45 degrees and 90 degrees. That means these angles are in the first quadrant. Theta over 2, that angle is in the first quadrant. So everything would be positive, or basically all of these values that we are going to find will be positive because this theta over 2 is in the first quadrant. This is in the second quadrant. So let's go ahead and draw the reference triangle again. So we have the angle theta in the second quadrant. So the reference triangle is going to look like this. So this is theta, this is the reference angle. So we have negative 3/4, so it's y over x, so x is negative, and the r is 5. You can find r, okay? So we are already given that tangent theta equals negative 3/4. Now from the reference triangle, we can find sine theta equals y over r, which is 3/5, and then cosine theta equals x over r, which is negative 4/5. Now, in order to find sine theta over 2, so we'll use the formula, this formula, sine a over 2, and we know that it's in the first quadrant, so we'll just take the positive. So sine theta over 2 equals square root of, so this is a, okay. So square root of 1 minus cosine theta. 1 minus cosine theta is negative 4/5, so this is 1 plus 4/5 divided by 2. And that becomes, so this is the numerator, is 1 plus 4/5 is 9/5. So 9/5, but we have 2 in the bottom, so it becomes 9/10, which means we will get 3 over square root of 10. Similarly, the second one is cosine theta over 2. So cosine theta over 2 equals, so we'll use this half angle identity for cosine. Again, it's in the first quadrant, so it's positive, so it is square root of 1 plus cosine A, but cosine is negative 4/5, so this becomes 1 minus 4/5. Okay, so 1 minus 4/5 divided by 2. So 1 minus 4/5 is 1/5, but we have that 2 in the bottom, so that becomes 1 over 10, and then square root of 1 is 1, so it's square root of 10. So that is the value for cosine theta over 2. Now to find the last one, which is tangent theta over 2, we can basically do sine theta over 2 minus cosine theta over 2, or we can also use one of these identities. So I'm just going to do sine theta over 2, which is 3 over square root of 10, divided by cosine theta over 2, which is 1 over square root of 10, and that gives us 3. So we'll just do this much for this video. I'll see you again in the next video.